There is a huge focus of research and implementation on making the large language models smaller and faster. In this video, I am going to discuss with you one such approach. The thing is that pruning weights from a neural network makes it smaller and faster. We have seen in lot of research papers. If you are following my channel, I have described it in great detail. But still, the problem is that it takes a lot of computation to choose the weights that can be removed without degrading the network's performance. If you don't know what exactly the weights are, let me give you a very quick overview of weights of the model. Weights within the model or LLM refers to the value within the model that determine how input data such as text is processed and interpreted to produce the output such as completing a sentence. Think of these weights as the knobs and dials inside the model that have been carefully adjusted through a process called as training, where the model learns from the vast amount of data. During the training, the model adjusts these weights to get better at making predictions like understanding context or generating text that makes sense. The better the weights are adjusted, the more accurately the model can understand and generate language, making these weights crucial for the model's ability to function effectively. So, this is what weights are. Going back to what we are discussing, now these researchers, which you can see on your screen, they have devised a computationally efficient way to select weights that have relatively little impact on performance. So, really, hats off to them. They are from Carnegie Mellon University, Facebook AI Research, Meta AI, and Bosch Center for AI. And this method is simply amazing. And this is a method for pruning by weights and activations or VANDA. Now, the popular approach known as magnitude pruning removes the smallest weights in the network based on the assumption that weights closest to zero can be set to zero with the least impact on performance. Meanwhile, unrelated work found out that in very large language models, the magnitude of subset of output from an intermediate layer may be up to 20 times larger than those of other output of the same layer. And I have done another video on this, so I'm not going to go into that detail. So if you look at this work, here the researchers have proved a pre-trained llama that started with 65 billion parameter and then given 128 sequences of tokens drawn from a curated dataset of English text from the web. The model processed them as follows. First, for each intermediate layer, the authors computed the magnitude, which is primarily the magnitude across all the input sequence for each value in the embedding. Then, for each weight in the model, they computed its importance by multiplying its magnitude by the corresponding norm. Then, they compared the importance of weights in a layer weight matrix row by row, that is, or a neuron by neuron, which the weights are also called. They removed 50% of the least important weights in each row. So, afterwards, the researchers tested versions of Llama unpruned and pruned via various methods. The model performed a language modeling task using web text. The unpruned llama achieved a 3.56 perplexity, and the perplexity is a measure of likelihood that a model will predict the next token. Lower is better value. Pruned by Vanda to half its original size, it achieved 4.57 perplexity, which is huge. Very fine. Also, when they used the computing method sparse GPT, it achieved the almost same score. But Vanda took 5.2 to prune the model, while sparse GPT took 1353.4 seconds, which is a huge difference. Can you believe that? Now, this is very important because this ability to compress neural network without affecting their output is becoming more important as models are increasing in size and devices are still not that powerful enough. So, smaller the model, we will be able to run them easily. Also, Vanda compared weights from each row in the weight matrix rather than each weight matrix or the model as a whole. The scale at which weights are compared turns out to be the real important factor. So, really excited about this. I think we will be seeing a lot of other efforts and implementation of this, and I believe that this is the right way to proceed in the future. That's it guys. Let me know your thoughts in the comments. If you like the content, then please consider subscribing to the channel, and if you're already subscribed, then please share it among your network as it helps. Thanks for watching.